Hello students, myself Amrendra Mishra. I am continuing the video lecture class on Bernoulli's theorem. In the earlier video class, we have discussed about the derivation part of Bernoulli's theorem. Now, how to state Bernoulli's theorem? It states that for a perfect incompressible fluid flow from one section to another in a continuous stream, total energy of fluid particle remains constant. The total energy is the algebraic sum of pressure energy, kinetic energy and potential energy. According to Bernoulli's theorem, we have total energy per unit weight of fluid is given by P by rho g plus V square by 2g plus Z is equal to constant, where P by rho g is known as pressure energy per unit weight of fluid, V2 square by 2g is known as kinetic energy per unit weight of fluid, and Z is your datum energy per unit weight of fluid. Let's come to the limitations of Bernoulli's equation. As we have seen that for derivation of Bernoulli's equation, we are assuming that the fluid is ideal. But in our real field, there is no fluid they are having with viscosity property. All are having viscosity property because which there is a flow of liquid resistance to that of the liquid takes place. While the flow of liquid taking place inside the pipe, the Bernoulli's equation does not consider the force of friction which offered by the wall of pipe during the flow of liquid through the pipeline. Due to this force of friction, there is a variation in velocity of liquid takes place. That is also not considered in it. Due to the friction in pipe, the internal surface of the fluid of pipe and the external surface of the fluid that are sliding contact with each other. Due to this sliding contact, there is a force of friction arises which may causes loss of energy and which is neglected in Bernoulli's equation. It is assumed that the flow of liquid is laminar, but it is not happening. Due to some contaminants or other particles remain inside the pipe due to the friction, there may be the chances of turbulent flow, which is not considered in the Bernoulli's equation. The Bernoulli's equation does not take into consideration of loss of energy due to change of direction. These are all the limitations of Bernoulli's equation. Let us consider about the application part of Bernoulli's equation. If you are considering Bernoulli's equation for a pipe and the pipe is having inlet and outlet, then the Bernoulli's equation can be stated as P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g, where pressure head is known as P1 by rho g, datum head Z and kinetic head as V square by 2g. Now, there are three applications of Bernoulli's theorem which are in following. The Bernoulli's equation is used for the measurement of discharge of liquid flowing through a pipe, Also, it is used to measure the velocity of the fluid, as well as it is used to measure the coefficient of discharge of liquid. So, there are three types of devices are used for measurement of velocity, measurement of discharge. The three components are or devices are venturimeter, Pitot tube and orifice meter. Later in the video classes, we are going to study about the working principle construction of venturimeter and also how to find out the discharge of liquid flowing through a pipe. Thank you.